So let's talk about radical inequalities. Now, we talked when we were learning about quadratic inequalities about this idea of using a number line to solve an inequality. And basically the way we worked with that is we solved the inequality as if it were an equation, and then we took those answers and placed them on a number line, and then we took test values off of each of the intervals on the number line and plugged them in the inequality to see if it worked or not. And then we wrote our answer. So the process for doing inequalities with a number line actually comes up in a lot of different areas, and this is the next time we're seeing it with radical inequalities. So just like before, we're going to end up solving an equation, and we're going to end up placing numbers on a number line and plugging in numbers to see if intervals work and writing our answer. But we have an extra step with these radical inequalities. And the first is to find the domains of all these radicals. So remember we talked about when we were graphing square root functions that you find a domain by setting the radicand, that's the thing under the radical, greater than or equal to 0. And then you solve. Now, this tells me that in order for anything to work in that radical, the x value has to be greater than or equal to negative 1/4. So I'm going to draw a number line, and I'm going to put negative 1/4 on the number line. Now, anything that's not greater than or equal to negative 1/4 is not in the domain of this thing at all. So automatically, I know that part is not going to work in the inequality because it's not part of the domain. So when I go to check numbers, I don't even have to worry about that part of the number line. So now that I've done the domain, let's talk about the associated equation. So the associated equation is basically the inequality, but written as an equation. And we're going to solve that just like we've solved radical equations before. Subtracting 3, dividing by 2, squaring both sides, then solving the resulting equation for x. And I would check it back in just to make sure it works, and it does. You can check it on your own. So I'm going to take that 2, and that is also going to go on the number line. Now, this number line is now divided up into 3 pieces. And we already know one of those pieces is not going to work because it's not in the domain, the part that's less than negative 1/4. So now what we have to do is choose numbers from each of the intervals and plug it into the inequality. So I'm going to choose 0 from this interval because 0 is easy to plug in. And I'm going to choose, let's say, 3 from this interval. Now, when I check these things, you're plugging it back into the inequality at this point. This is the first time you really use the entire inequality. So I'm checking 0, and I want to know if this is true. So I do the math on the left-hand side, and I find that 5 is not greater than 9. So this part doesn't work. So then I go and check 3. And again, the idea, you plug it in. Whoa, that is not what I wanted to write. That's a 4 times a 3. So this is 3 plus 2 times the square root of 13. And square root of 13 is somewhere between 3 and 4. Now I could pull out a calculator and get the decimal for it. But if this is bigger than 3, then this whole thing is bigger than 6. And this whole thing is going to be bigger than 9. So this part is the part that works. So the last thing I have to do is write my answer. So I started with a greater than, but no equal to, and I got all these numbers over here, which are the numbers that our x is greater than 2. All right, so let's talk about the problem at the bottom. Same idea, slightly more complex. So the very first thing we're going to do is get the domain. Now this time we have 2 radicals, so since they're both square roots, x plus 8 has to be greater than or equal to 0, x plus 3 has to be greater than or equal to 0. So when I get these 2 things, when I go to draw my number line and mark out the things I can't get things less than -8 because the domain has to be greater than -8. And I can't get things less than -3. So nothing on that side of the line will I have to worry about checking because none of that's in the domain. So now we're going to solve the equation. And you saw how to do this in the first video that we did. We're going to isolate a radical. And I'm going to choose to get x plus 8 by itself. Then I'm going to square both sides. And remember, the thing on the left-hand side, the square and the square root directly cancel. But the thing on the right-hand side, we actually have to multiply out because there's a sum on the inside. So I'm going to multiply that by FOILing. So I would get 1 plus 1 times the square root of x plus 3, and another one of those 1s times the square root of x plus 3, and the square root of x plus 3 times the square root of x plus 3 is x plus 3. I combine like terms. So I've got an x, I've got a 1 and a 3, and then I've got this square root and another one of those square roots. So now I'm down to 1 radical, so I'm going to work to get that one by itself, subtracting x from both sides, subtracting 4 from both sides. Divide both sides by 2. Square both sides, and then solve for x. So that number is going to go on the number line as well. So now again, I need to check my answer, and this might be one of those places where again I pull my calculator out and use it to help me out with the arithmetic. So I'm going to choose, say, 0 here, and then maybe 4 here. Could do 3, could do 2, doesn't really matter. When I plug in 0, you're going to get the square root of 8 minus the square root of 3. And I'll write that down. So we're checking 0, plugging in 0 for the x's. I want to know if that's less than 1. So I get square root of 8 minus square root of 3, and I may not know those off the top of my head, so I pull my calculator out and find that square root of 8 minus the square root of 3 is 1.096. Definitely not less than 1. So now I'm going to check 4. So I plug 4 in for the x's. So then I'll get the square root of 12 minus the square root of 7, and I want to know if that's less than 4. So I pull my calculator out, I do the square root of 12 minus the square root of 7, and I get 0.818. So that one does work, and then I write my answer. All right.